Hello, everyone. Let's wait a few moments for everyone to join. How has everyone's day been so far? At least for me, it looks a little bit cloudy, but we'll figure it out as we go. Let's just wait a few more moments for everyone to join. Alrighty, I think we shall begin now. Once again, hello everyone. My name's Daniel, and today we are talking about contract testing, ensuring that microservices can communicate with each other. As I told you before, my name is Daniel and I'm your host for today. So, what are we going to talk about today in our webinar? What is this webinar about? First, it's about what is contract testing in general. What is a consumer-driven contract? What does that actually do for us? What does the contract testing workflow look like? What are the tools and the ecosystem behind it? What can we actually use to make use of the contract testing? Then I give you a contract testing example in terms of code, so you can have a little bit of an insight what we are going to do with the actual contract testing, besides having it in our mind to actually write it down and use it. At the very end, I give you some best practices, what you shall do and what you shall not do. At the very end, after our best practices, we come to the conclusion why you should use it and what's the point of having it to begin with. So I'm going to give you a baseline definition of what contract testing is. Contract testing verifies that two systems, in this case, a consumer and a provider, adhere to a shared agreement, a contract, about how they communicate. So you can basically think of it as we set in stone what one shall provide in terms of what we request, and on the other side, what we get back from the request. In this case, our response. And this is being held in written form inside of a contract that we use for our contract testing. What does a so-called contract specify? Well, we have three basic points for that. In this case, the available endpoints. In this case, we are talking about a backend service. That is where the contract testing comes into play. So, for example, we have a software that has the endpoint test, for example. And inside this test, we have some expected requests. For example, test/user, where we request all the user data, for example. And then also we can write down the expected responses. So if we say test/user, that's our request, and the expected response shall be that we get a list of all users when we request it under this endpoint. That is what a basic contract is going to look like. What is the goal of the contract testing? Well, easy. It's ensured that both sides remain compatible, even if they evolve independently. You can think of it as we have a static front end, but in the back end, there's going to be some changes regarding, I don't know, for example, we are talking about a bank, and the bank now decides we want to offer more information or even retract some information that has been provided before. So in this case, we have this contract that specifies, okay, we give it this, and that, and we get certain data back. So it can evolve independently. The front end can show more or less independently of the back end that can provide XYZ, for example. An analogy could be a legal contract. The both parties must fulfill their promises. If the promise is broken, the deal is broken in itself and the contract is void. Same deal with the contract testing. If one side, even the request or the response, differs from the contract, we have a broken deal and it will not work out anymore. That's the basic gist of contract testing. Speaking of contract testing, we are talking mostly about consumer-driven contracts. Why this specific name? In consumer-driven contract testing, in short CDC, the consumer, that's important, defines the expectations for the provider's API, because usually it's the provider that sets the expectations of what you can send to him and what he sends you back. But in this case, we are talking about the consumer that defines the expectations of what is going to get sent and what we will receive back in this case. For an example, we have a front-end team that defines the response structure they expect from a back-end API. So the back-end team basically provided us with information XYZ, and now the front-end team comes back to them and tells them, so we sent you, for example, the user request, and we get all the data back from them. And this is what is getting defined in the consumer-driven contract. The provider in this case verifies regularly that the API still fulfills the expectations. In this case, you can turn it upside down. Not the consumer is actually the one that wants to check it. Of course, he wants it too, but the provider as well. He wants to verify that everything that we will send him matches what he expects that we wrote down in our contract, that everything matches up and everyone is happy at the very end. Because as a provider, you also don't want to get malformed requests, which could, in theory, lead to unexpected behavior and even broken services, which we, of course, don't want. So, what are the key benefits of the consumer-driven contracts? Of course, we have improved communications and accountability between the teams. Once we set down the consumer and the provider and write down a written contract, everyone has the same expectations. We have improved communications in terms we sit down and talk to each other and verify that everything is written down in the best terms for both parties, as well as accountability, because once you write down your contract, you are liable for the stuff that happens afterwards, right? In this case, it's also some sort of ownership that gets created for both parties. We will get immediate feedback if the API changes that breaks for the consumer. Of course, when you are the consumer, you are the one that is reliant on what the provider provides for you. And in this case, we have the front-end team that wants to display some data, but if it can't, then yeah, everyone blames the front-end team, but they are not the ones to blame. So we get immediate feedback if anything changes at all. And that's really important. We can give you a short example. Of course, I told you so already. The consumer expects a /user endpoint that returns, for example, an ID and a name. So what happens if the backend, for whatever reason, wants to change name to full name, for example? The contract will instantly fail, showing us that the contract has been broken and something fishy is going on. Since we know where the information came from that was invalid, in this case, not from the consumer, the provider is to blame, so to say, but in this case, we know where we have to tackle the problem instead of looking at the consumer side, because he just sent the request the same as he was doing before, adhering to the contract. The provider is the one to have to create a bug ticket for this in this case. Right, so let's get over to the workflow in this case. What does a typical workflow look like when we are talking about contract testing? The consumer creates a so-called contract. We were talking about that before. He writes down tests, simulating interactions with a mock provider. In this case, we are talking about the contract file, which is usually provided in JSON form. Later on, I will show you what it's going to look like in the demo. And I can give you a quick example. A contract could look like, when I call /user/123, I expect the HTTP code 200 with a JSON body containing the name. That could be a basic contract that everyone can agree on in this case. The contract then is published, is stored in a shared location, for example, with PactBroker or PactFlow. Later on, I show you some different softwares that we can use for our contract testing. Those are just some examples. The provider then verifies the contract. In this case, he retrieves the contract and tests whether its real API meets those expectations. We send it over. It checks, yeah, we should send back, for example, ID and name. And it checks if that matches up with what it actually sends back. If the verification passes, both sides are compatible and the contract is okay. We can also talk about automation in our contract testing, because contract testing is perfectly suitable to being integrated into CI/CD pipelines. What does that mean? We can send those or set those contracts in our repository, for example, in our pipeline with the appropriate software, for example, Pact, and regularly check if the provider, for example, changed the specs for whatever reason. And in this case, we would get immediately feedback about a broken deployment. We get fast feedback. We get immediate feedback about blockages. Why is that important? You know, in our day and age, time is money. Never been truer than right now. And immediate feedback means that we can immediately react to it. And what you never want is having software that is broken in production, which could happen. But we try to fight that back with our contract testing. Right. Speaking about contract testing, let's talk quickly about the tools and the ecosystem behind it. I've written down a little list of what you could possibly use, what it's used for, and what languages it usually covers. The prominent example would be Pact. It's a widely used open source contract testing framework. It's written in multiple languages or available in multiple languages, for example, Java, JavaScript, Go, etc., etc. What you could also use is PactFlow. That is basically Pact, but as a cloud solution, provided as a software as a service. Easily integratable into CI/CD pipelines, just not hosted on your machine, just hosted in the cloud. If you want to go to the cloud, that would be an ideal situation for you. I, for myself, am not that huge of a fan because I like on-premise software, but you do you at the very end. What I've been using lately is the Spring Cloud Contract. As the name implies, it's contract testing for Spring Boot services. Ecosystem-wise, of course, speaking about Spring, it's Java and Kotlin based. So you have the best integration for that. In my opinion, no other tool matches that in terms of Spring Boot compatibility. When we talk about Node.js, Dread is the one that you should go for, if not Pact. Validates the API implementation against an open API spec. Of course, you would need that, but if you have that situation, that is a good candidate to use instead of Pact, because Pact is so dynamic and Dread is a more specialized tool for that. You can decide on what is easier for yourself. What you can use locally is Hoverfly or Mocklab. In this case, it just uses REST or HTTP requests in this case. It's API mocking and a verification tool, basically. Instead of the other ones where you tightly integrate it into the code, for example. In this case, we are having no real attachment to any programming language at all. It's more like a tool that you use on a regular basis, for example, like Bruno, where you just set up your REST calls or HTTP requests or whatever. So that's the most adaptable if you're not that into the code. Right. Typical CI/CD integration. What does it look like? A contract verifies automatically with each build. What I told you before, everything runs automatically. So no manual work, more reliable at the very end. The results get reported in dashboards or in the pull request as well. What does that enable us to? We don't necessarily have to go to a developer or a product owner or whatnot. Everyone can just pull up the information on a website, for example, so it makes everything easier. If anything goes wrong, everyone is going to be aware immediately. What does that enable us? Of course, can I deploy it safely? It's a check all across the teams because everyone is able to see if something got messed up in the latest merge request or if something broke, for example, in the last deployment pipeline. I don't know. Everything's possible, but in this case, we have a fail-safe mechanism using the contract testing. Right. So I want to give you a quick example code-wise what that could look like. In this case, I have a little code snippet for you that is written in TypeScript, or in this case, JavaScript, if you want to, where we use packed. We are generally describing what does our pack look like. We are providing it with a new so-called packed, where we describe who's the consumer, in this case, the front-end app, and who's the provider. Why do we need to provide that? I will show you a little snippet for that as well. That snippet on the right is for the Java side of things. In this case, it's a Spring Boot service. Yeah, I detected some of the code just stating, yeah, that verifies that the real provider API matches the contract. And if you see that little annotation up top, add pack verification front-end app. That's where we tell it, yeah, that's connected to the consumer front-end app. That's why we stated it inside the packed. The name of the class is called user service pack test because we stated the provider is going to be the user service. That's just describing the pack and the provider, we call it here in the code. The real test begins afterwards. It should receive user details, and then we wait for the provider to add our interaction. In this case, upon receiving a request for user one, we are looking for the request that acts as a receiver for user data of user with the ID one. With the request method, in this case, get, and the path is going to be /users/one. That's the path that we are actually calling as the request. Afterwards, we want to check if the response matches up with what we expect. In this case, we will say, we'll respond with and provide it with a JSON body. In this case, the body contains the ID 1 and the name Alice. The HTTP status should be 200 in this case. What is going to happen at the very end? The outcome is if the provider renames name to full name, for example, the verification fails immediately, catching breaking changes early. We can let that run basically anytime we want, basically on the merge request, on any CI/CD pipeline that is running concurrently, whatever. And in this case, we are verifying that the service does actually what we want on both sides, on the request side of things and on the response side of things. That's a huge plus for everyone that it has some stocks in that situation, the backend as well as the front end team. Right, some benefits and limitations that we have. Core benefits are we are detecting breaking changes early. There is no need for us to wait for any new updates regarding what the backend should look like, what they want to receive, what they put out. Anything gets basically automatically checked for us in this case. It's fast and isolated. There's no need for full integration environments. You're just basically checking, yeah, do we give it the same? Does it break? Does it put out the same? Does it break? Everything matches up the way you described it in the contract beforehand. It makes stable and reducible tests. In this case, since we have written it down, what we give it and what we want to receive from that, everything is reproducible in a matter of seconds. There is no need for changes other than we want to have changes on the contract itself, but that's another story. If we want to have the same results, we can always run the same contract test. It will always produce the same tests and results in this case. We have clear communication between teams. Since both teams, in this case the front end and back end team, had to communicate and set for a defined contract, the communication between the teams is clear and concise. Everyone has given their thumbs up for that, and that's what we adhere to at the very end. It's ideal for continuous integration and deployment. Since we can run it over the CI/CD pipelines all the time, it's just the perfect candidate for actually improving our confidence in the code that we are providing. What are some of the key limitations that we have? It's not a replacement for end-to-end tests, since it doesn't validate business workflows. That refers to, it just checks if we are putting in XYZ data and getting out ABC, for example, but it doesn't have a focus on what actually gets done with this data. Where does this data come from? Where does it go? That's not what it checks. So it's no feasible replacement for an end-to-end test. It's just verifying that we adhere to the contract. What do we provide it? What do we get from it? So watch out for that. Don't fall into that pitfall that you might be too reliant on contract testing. There is a little bit of management overhead when you have many consumers. In this case, for example, we could have the situation that we have one backend, but multiple front ends are attached to it. And in this case, we could have the situation that we have more consumers that have different contracts. And that could lead to more overhead because you need to check each and every single contract at the very end, which could be really, really time consuming. And of course, we are moving more and more towards asynchronous systems. For example, Kafka, it gets very complex at the very end. And yeah, there are some solutions to that, which I will get to later on. But let me tell you, it's gonna be rough. At the very end, we also have the problem that it requires discipline with versioning and ownership. The problem here lies that the versioning needs to be basically in line with what the front end and back end team does. And ownership is sometimes a little bit on the iffy side. If you are not really disciplined and using contract testing, the situation could arise that neither the front end team nor the back end team feels responsible for it. No one wants to handle that stuff if something breaks. So that could be a huge issue. So please, if you are a rookie or have rookie and teams that are not being managed by a higher up or a senior level developer, for example, please tread lightly, because that could result in a disaster, basically. Everyone blames each other and no one gets stuff done at the very end if something breaks. So watch out for that. I want to tell you some of the best practices that I've learned along my journey. Keep the contract versioned alongside the code. If you don't want to have it in both repositories for both sides, keep it in one place, but keep an eye on it on both sides, backend as well as front end, or whatever situation you might face. Keep it versioned. Keep an eye on that. Keep it updated. Automate contract verification in CI/CD pipelines. Early on, if you are implementing that stuff, please, please, please message your DevOps experts and get them into the boat as early as possible, so you don't have to run that stuff manually and everything gets automated. As I've told you before, contract testing is one of the best candidates for actually having implementation in the CI/CD pipeline. It's getting automated easily once it's done, right? So please do that. For example, use the packed broker or packed flow for sharing a visualization contract. That is a software that you can use to actually show people what you're doing instead of having this weird JSON mumbo jumbo, packed broker and packed flow actually do some visualization magic for you. I can highly recommend those. Give that a check. You can just Google that and you will easily find the software there. So you might want to give that a look if you are going to approach the situation of using contract testing. So maintain a good communication between consumer and provider teams. I told you before, since you have a contract that you both try to adhere to, the communication in general should go up. Since you both have to agree on updates, maybe you as the front end team want to provide it with more information that maybe gets digested in some sort of way that outputs more data. You can provide the backend team with that information and agree on a new contract. And the other way around, if you need some additional data that you want to digest in the backend team, you can always go to the front end team and agree on a new contract that you get more information in, that you can then calculate to, I don't know, whatever you want. Maybe a MFA token that now has to get sent as well in addition to the ID and whatnot. I think you get my point in this case. Regularly clean up obsolete contracts. As you might be aware, sometimes you try to rewrite older backend services. And in this case, you might have a contract that, for example, sets the endpoint /users and then /ID, but you want to change it. Then you have a completely new contract for user/name/ID, for example, because one user could have multiple user accounts under the same name, for example. In this case, the first contract is now obsolete. You don't want to have it linger around in your code. So please, please, please clean up your stuff regularly. If you are aware that something changed, broke, whatever, you get the point. As I've mentioned before, when we go to asynchronous APIs, maybe you want to switch to message-based contracts. For example, what we can use is packed message for Kafka. That is packed in a message-based format, specifically tailored to match the Kafka wants and needs. You might want to give that a look. But, usually I would describe it a little bit more, but I think our time constraints would then be out the window. Right, so that's basically it. A little conclusion to what we've learned today. The key takeaway is going to be contract testing enables fast, safe, and reliable collaboration between independent services. In this case, we are talking about what are we going to send, what are we going to receive, or the other way around, if we are the provider, what are we going to receive and what are we going to send out. Both independent services enables huge and easy collaboration since you both agree on the contract, what data you send, what you receive, whatever. It greatly reduces integration risk because once you are fairly certain, or 100% certain in this case, that the data you receive matches what you want, the risk goes down to basically zero if everyone adheres to your contract. It saves time in QA and debugging since you basically know exactly where the problem lies. Does it lie in the data provided that you send it over as the request, or is it in the response? In this case, you can narrow it down, make it easier for the QA as well for the developers that actually have to fix the bug at the very end. It builds trust and confidence in the deployment since every time a deployment happens, if you've set it up in a CI/CD pipeline, you're 100% certain that everything checks out according to the contract that you made before with the other team. In short, test the contract, not the system, because at the very end, you are checking for what the contract says. You are not doing system testing with contract testing. You are just verifying that the request and the response matches with everything that you set it out for, not the actual business information and the business side of things, just the contract, not the system. Keep that in mind. And by saying that, we are done with the regular part of our webinar today. Do you have any questions so far? Please let me know. I'm happy to answer any questions that are coming up. Don't be shy. So, if there are no questions so far, hang on a second. Then I will thank you very much for attending today's webinar. We at Go Bigger have some current offerings. If you haven't already, maybe give us a follow on LinkedIn. You can find us under Go Bigger GmbH. A follow would be greatly appreciated since it helps us spreading awareness about us, about software testing in general, and keeps you up to date on our latest LinkedIn posts. If you're interested, you can also check out our current courses and our workshops. You can find it in our website, go-bigger.de/shop. There you will find the latest and greatest courses that we provide. In this case, we are providing our robot framework course that prepares you for the RFCP. Give that a check. And if you want to, you can buy the course directly. Have at it. And at the very end, I want to show you our monthly newsletter called Grow Bigger. Each and every month, we send out only one email stating the current events that are happening in the software testing side of things, specifically in the robot framework world of things, because we are also part of the Robot Framework Foundation. If you don't already know, just one email per month. You can always unsubscribe if you're not happy with it, or I don't know, for whatever reason. You can always message us if you want to improve things. But besides that, thank you very much for tuning in. My name is Daniel, and I wish you all a happy day. Thank you very much.